you don't have to do that. Is everyone excited for data warehouses? Everyone excited for the weekend? Okay, that's fantastic. So I work for a company called SQream. I'm going to show you some of our insights from this, and these are strictly our insights. You can agree or disagree, and you can come, punch me afterwards if you disagree. So despite my accent, I'm an Israeli. I live in Copenhagen, which is also bizarre. I don't speak Danish. I've spent the last 5 years at SQream, and I started actually by developing our data warehouse. So everything you hear is from my perspective. I tweet a lot about animals and airplanes if you want to follow me. It's kind of boring, but whatever. So the first question we have to ask is, what makes a company competitive? Anyone? No, data. Data is what makes companies competitive. We've seen this again and again, specifically in industries where the hard product tends to be kind of similar. If we look at telecoms, which is where I'm going to take this in the end, telecoms have a very similar kind of product. The 4G LTE network, or the 5G in some cases, is mostly the same for most companies. And how they differ is in what kind of products they can offer. And that product offering tends to be data-driven. So you ideally want to analyze as much data as you can, and telecoms, for example, collect a lot of data. And you want to match your products to your customer. That way you reduce churn, you reduce people leaving you, and you can just improve your offering. So I mentioned telecoms collect a lot of data. I'm not going to show you a graph of how much data is being collected. You've all seen this probably 500, 600 times. These many tweets per minute, this many Facebook posts per hour. It's not really relevant, but companies collect a lot of data. I'm sure you all know this. The problem is most of the infrastructure has not really caught up with this kind of collection. This is an article that was published late last month on Forbes. The big data revolution will be sampled. How big data has come to mean small sample data. This is a problem with infrastructure. The data is being collected fine, but you can't really analyze it because it's just so vast and varied, and it changes and it becomes irrelevant really quickly. So what most companies do is they sample. They look at a small percentage of the data. And I have a question. How much percent of time do you think is wasted, or spent, let's put it that way, on data preparation? 40%, show of hands? 50, 60, 70? Yeah, okay, 70%. So you're actually, I'm going to stop at 70. Gartner says 60, but from what I know, it's a little bit more. So Gartner is actually being quite conservative here. But 60% of time on data prep is already a lot. And what that results in is most of your data not being analyzed, either at all or on time to make it relevant. So basically what we're hearing, and this is quite common, we're only looking at 10, 20% of our data. We have so much data and it takes longer and longer to analyze it. But in my opinion, the most powerful thing is this one. Existing systems are limited for our current needs. That's actually the underlying issue. That's not the symptom. The symptom is we're only looking at 10%. The underlying issue is our systems are just not designed for this, not ready for this. We're going to have trouble scaling them, or are already having trouble scaling them. The biggest thing we see today is one of two things. First of all, MPP databases. So this is something that Oracle Teradata actually pretty much pioneered in the 80s. And we're still on kind of that same architecture with a lot of MPP databases, massively parallel processing databases. These are distributed databases that have hundreds and thousands of CPU cores, and they're distributed, and they try to tackle this problem. And while they I'm sorry if I'm rushing, I don't have a lot of time. Originally, these were amazing solutions, but they did not advance with the changes in data scale and size and the speed and the variety, and they've kind of been left behind. So there is another solution that came about, and we'll talk about that in a second. But what MPPs end up with today is a very complex architecture full of workarounds. So you have your data sources, which is not going to change. Some of them have to be correlated, some of them have to be cleansed, some of them have to be converted in order to be loaded. This is all fine. They go through an ETL process. They're either loaded directly or go through an ETL process into a database. It could be one database. It could be 50 databases. Some companies we know have over 100 different types of database. And that's fine. I mean, you should really match the database for your workload. So let's assume that's one database, okay? Then you typically want to compress it. This is a relatively modern concept because today's CPUs can compress pretty well. So you end up compressing data to try and save on disk space. You also do partitioning in order to make sure that everything is split up correctly. But that's not enough. I have some text. This says pre-computations in case you can't read that. There's a bunch of other processes that you have to go through in order to have the data ready to be queried. So while technically you can ask the database right now, select, aggregate, sum, order by, group by, whatever you want to do, it's going to be excruciatingly slow. And you're just going to have to stop this process eventually. So all these workarounds, some of them all exist in the same database product. Some of them are, database specific. But cubing, projections, materializing views, pre-computing tables, creating aggregated tables, these are all very, very common practices for data warehouses. And they've come to kind of answer a specific need, which was we want to get our queries done faster. But what they do is they actually limit you. Because if you now want to say, you're a telecom. I'm going back to the telecom example. I'm sorry. You want to start correlating data that you haven't thought about before. You want to start correlating geospatial data, for example. You want to find out where people spend their time. But you hadn't indexed that table. You hadn't created a cube for this. So you have to ask your DBA to do that for you. And the DBA will say, well, we can't because we have to ask IT because it's going to take a lot of extra space that we don't have. So you have to start signing forms. And you have to get them approved. And it can take months for that to happen. We've seen that in large companies. In a small company, it may not be such a big deal. But in large companies, this can take months. And by the time that that is ready, the data may not be relevant anymore. So this really limits the kind of depth of analysis that you can do. So while it answers one problem, which is speed, it limits you on the other hand. The other problem is Hadoop and Hadoop's friends, which I'm not going to name each of them because there's just so many of them. Hadoop really caught on, which is fantastic. And Hadoop was designed for primarily one thing, collecting large amounts of data and scaling it out relatively cheaply, which it has done, and it does that fantastically. And it does MapReduce, which is also fine. But it was not designed for analytics. It was not designed to be a database. There are companies using Hadoop as a database. And if that works for them, that's amazing. What we see is it's not designed for example, doing joins, because you have to start moving data around the network, which becomes really expensive computationally, not just in money, but also that. It's not really good for high concurrency workloads, and it's just not designed for relational access. So if you're a company that does SQL, and you introduce Hadoop, you're going to have to start finding a workaround, right? You're going to have to find an SQL on Hadoop style solution, which translates it to operations that Hadoop can actually do, which is MapReduce. So what did companies end up doing? Some of them just kept their traditional data warehouse, MPP data warehouse or whatever. Some of them are trying to work within the confines of Hadoop. And for some companies, that works really well. But for most, from my experience, it does not work that well. So they start to add additional things on the side, and you add Spark SQL and you add Kafka SQL and all these different SQL-style solutions, which begs the question, why not just do SQL, right? And then the most common solution that we see is deploying both Hadoop and a traditional data warehouse side by side. Enterprise Hadoop deployment can also get quite messy. This is an example that I found that some companies are really proud of this. Look at this deployment that we did. It's so complex and fun, and this causes me severe pain to look at, so I'll just skip over this. The question is, what if we could do this better? And I'm sorry this is going to be talking about our own product, but we're not the only product that does that, so just keep that in mind. Our product is called SQreamDB, and it's a GPU-accelerated data warehouse. So data warehouse, you all understand. A GPU is kind of a weird thing here. A GPU is an NVIDIA graphics card. It's designed for graphics initially. Today, it's more enterprise ready. When we actually built our database for the first time in 2010, it was not enterprise ready. We could not take a GPU card, stick it in a rack mount server, and be happy, because it was not designed for that. But luckily, the industry has gotten other companies that do deep learning, machine learning, even crypto has made a really, really big impact on GPUs for us. So now you can find GPUs everywhere. So our product is powered by GPUs. We do not use a GPU to make one single query run faster. There are companies that do that. They will keep all the database in memory, and they'll just load up what they have and process it and get you a result in 200 milliseconds, which is amazing, by the way. We use the GPU for its high throughput compute. So what we're actually doing is we're taking the MPP databases and we're condensing them down into a single card, the GPU card, together with the CPU and the RAM and everything else you have in a machine, and we're building essentially a supercomputer in a single computer in a small rack mount server. And what that means is we've actually designed a database that's supposed to offload data from your existing data warehouse or Hadoop or whatever you have. And that's important. It's designed to offload analytic workloads. A GPU database will not be good for everything. It's not like you think, oh, I'm going to stick a GPU in Postgres and it's going to be amazing. It doesn't work that way, unfortunately. We are designed for analytics. We're designed to offload. We will not give you everything Oracle or Teradata can do. So that's important to say off the bat. The main thing that we can do with a GPU that we are not able to do otherwise is work on raw data directly. So all of these workarounds that we talked about, the pre-computations, the cubing, all of that can be essentially eliminated because we have such a high throughput device in our server. We've designed it to be a standard database, so you have data coming in, CSV, Parquet, Storm, Kafka, whatever comes in, either directly or through JDBC, or ODBC if you choose to do that, that's fine. And on the other hand, you have your data engineers, your data scientists, your data analysts, BI people. They don't have to know it's a different database. It's an SQL database. It runs using standard SQL that you would get, with any other database. Connects with ODBC, JDBC, Python.NET, and all those words. So if you already have your BI tools, you already have your people writing Jupyter notebooks and getting data in and running their machine learning models, they can still use SQreamDB. They only have to point it to a different place. So we've kind of designed that to shift the flexibility back to the data engineers, the data scientists, because they're the ones who understand the data. It's not necessarily that the DBAs don't understand the data, but you don't want the control to be in the hands of IT, essentially. You want your people who understand the data, who want to use the data, who need to use the data. You want them to be in control over what they query and when and how. So I mentioned the GPU. This is the only meme in my presentation. I'm really sorry about this. A GPU has 5,000 cores. This one specifically has 5,120, which is most of what you hear about GPUs. They have 5,000 cores, which is incredible. It's not just the cores, though. The memory bandwidth here, 900 gigabytes a second for a single one of these, is just incredible. And that's what lets us do what we do. So we're actually more memory bound than compute bound. It's not that if we had 3,000 cores, it probably wouldn't affect our database that much. But the fact that we can push 900 gigabytes a second through this is just phenomenal. And think about what that means for sorting data, for grouping data, doing aggregations, mathematical functions, compressing data, decompressing data. It's just phenomenal. So with the standard data warehouse, what you do is you have your raw data. It goes through some type conversion, and you end up with a little bit less data. You can sometimes compress it on the fly. But once you add the indexing and the additional pre-computations, you actually end up with 25% extra on top of what was originally there. So that's 80 plus 25%, so that's 105. And only then is it ready to be queried, which is a problem. So what we do is a little bit different. We use the GPU on the load. We compress everything. The average compression ratio that we can do is about 1 to 5. And with our... Oh, OK. And after we've compressed it, the additional metadata that we have to collect with the GPU is only 1%. So that is what brings the flexibility. It's this compactness that we can get that's really important. So I actually want to show you this. You remember this? It was about 5 minutes ago, so you should remember this. This can become this, right? You've taken out all of the messy pre-computations that are difficult to manage that you have to manually refresh or automatically refresh or triggers or whatever you have, and you've just eliminated them, which is really, really powerful. And now I actually want to show you a use case because I think that's the interesting bit. And I have a demo in our booth if you want to come later. It's booth E40 on the corner. So AIS is a telecom in Thailand. They have just under 41 million customers. They're the largest telecom in Thailand. But there are small and upcoming telecoms which are really fighting them. They're really taking customers away from them. And AIS said, we want to run these more complex dashboards. We want to figure out where the people are. We want to find out if they're maybe loitering near our competitors' stores so that we can offer them something better. We want to find out if they're maybe not getting good network experience. So they were trying to do that with their current database, and they were kind of reaching its limit. And they were faced with a solution. Do we expand our current database? Do we add 3 more racks of this solution? Or do we try something new? And we were happy that they decided to try something new. So they called us over, and they had us do the same thing. So ETL the data in, just like we do with Greenplum, and run a complex query that is in 9 stages. Each stage builds upon the previous. There are window functions, group bys, mathematical functions. This was my first project at a customer site, and I was terrified. First of all, I don't speak Thai, so it's terrifying. And second of all, I did not know if it would work. So, being a developer, I'm a little bit pessimistic by nature. And I was terrified that they would run the query, and it would either give the wrong results, which is always scary in a database, just wouldn't run, or it would crash in the middle because they did not give us the server that we wanted. So we actually did it. And we took their 5-hour-long ETL process, that was ETL and the pre-computations, and because we don't need the pre-computations, we did it in 20 minutes. So 20 minutes end-to-end, data load to data ready to be queried, which they did not believe us, and they had us rerun this like 5 or 6 times, clearing the tables, run a select, show that there's nothing, load the tables, look at the data, verify, and so on. And then we ran the query, and it took 9 minutes and 40 seconds. So I mentioned some companies bring it down to 200 milliseconds. That's not us. We take hour-long processes, or 2 hours in this case, and bring it down to 10 minutes. And I could see their eyes widen up with the opportunity. And they said, let's change the query parameters. Instead of looking at 1 day, let's look at 11 days. Instead of looking at Diamond and Platinum subscribers, let's look at travelers who are on a prepaid SIM and visited Phuket in the last month. So they started really hammering us with different queries, which of course terrified me again, because I was not sure of our product because it was my first time. I do have to show you how that looks, though, the difference in what we were up against. That's the Greenplum. It's 5 racks, 7,600 CPU cores. And this is a reused server that they gave us. We said we want 256 gigs of RAM. They said we have 96. I said we want more. They said take it or leave it. So we took it because we wanted this project. And we had a single GPU in there. This is what we can do with a single GPU. And NVIDIA doesn't like hearing this because it doesn't shift a lot of cards for them. But customers like seeing this because one of those cards was $5,000. That's what it cost them to start this project, buying a GPU for $5,000. Modern GPUs are a little bit more expensive. They're $11,000 today, but still in the same ballpark. This is the kind of dashboard that we generated for them on the fly while we were sitting in the conference room with them. And this shows data usage throughout the day, bucketed by hours. So nighttime, daytime, when people are sleeping, over weekends, where are they spending their time? What kind of network performance are they getting? Are they using a 4G phone on a 3G network? Let's find those users and tell them to upgrade. They can get much better performance. So that's what we did. And this is a 3-table join running directly off SQreamDB with no pre-aggregations, no pre-computations. This is the architecture before. They had a lot of stuff going on here, a lot of pre-aggregations, a lot of daily reports running, and sometimes these would not finish. They would go to the office at 8 a.m. Every process that is still running overnight is killed so that the BI users can get what they want. And this would mean sometimes they did not have their daily reports and they had to wait for the last 7 days of the month when the system is allocated some more processing power and can actually run the monthly reports. Their slowest report took 5 hours to finish. A lot of time. What we did is we cut out all of that messiness. We could do the entire data load in 25 minutes, and that includes the others, which is the customer profiles, what kind of customer they are, what kind of handset they have, and all these different things that don't really update all that often. The 5-hour report went down to 10 minutes. That is the power of correctly storing the data and correctly accessing the data and using hardware acceleration. Now, I mentioned we're not the only ones who do this. There are other products on the market. For example, Netezza uses hardware acceleration, but Netezza is sadly a little bit on the decline. But we're happy to see some other products up and coming using hardware acceleration. And that's unfortunately all the time I have. So I'm sorry that I rushed it, but feel free to either catch me outside or come to booth E40, and we'll be happy to show you a live demo, actually.